Welcome. Today we're going to be taking a look at how we can do some really cool stuff by doing more complex queries by adding joins to it. So what do you mean by join? Well, so far everything we've been working with has been one table. I put in this table over here, this table here, and asking the questions to it. However, most of the time in database land, I'm not just asking one table questions, I'm asking many tables questions. And the way we make that happen is we pull those tables together by using the join command or keyword. And the syntax of the join clause is really important because just like all our other keywords we're working with, it's kind of a big deal how we organize the structures to make that happen. So let's go ahead and take a look at this. Let's take a quick flashback to our normalization assignment at the very beginning of the semester. Remember how we took those tables and we split them apart into piles? So instead of one giant table, we have a bunch of little tables. And we made a reference from one table over here to the table over here because this information links back to this. That's the primary key, foreign key relationship. And that path that we have between this table and this table, which might be indirectly through different tables as well, but that path we have is how we can actually make those tables get joined together and do queries on them. And the foreign key or FK of a table is going to be matched to the primary key or PK of the other table. So you have to make sure those primary key and foreign keys match directly. And if we have a composite primary key, aka we have a primary key that's more than two or more fields, we have to make sure we match all the fields that are shared between them. They need to match too. So let's take a look at how we can identify the path between some tables. Our first path we're going to take a look at right here is our student path to the zip code table. So our student and zip code tables share a single column in common. That's the zip table. It's the foreign key in the student table, and it's the primary key of the zip code table. So now, by using that relationship, I could find out information like the city and state of a student because of the relationship via the zip code. So I can find that information out and go from there. We have a more complex relationship right here between the grade and the enrollment tables. Now you can see right here in enrollment, I have two primary keys, the student ID and the section ID. And I look up at my grade table up above, and I have three primary keys. I have grade type code, section ID, and student ID. So two of those are in common. So whenever I want to join between the enrollment and grade tables, I need to make sure that both of those are matched up. Otherwise, I'm not going to get the correct amount of results. I'll probably get too many, which I don't want to see. We are specifically working with Equijoin. That's just a fancy way of saying we're making a join based on equality. I know. But it's a default join we're using for all of our work, and it's where we check to see if the PK, the primary key, is the same as the foreign key of the other table. So making sure PK equals FK. And again, remember that the order of that doesn't matter. PK equals FK is the same as FK equals PK. It works just like math. We're also going to be working with something called aliases. Aliases are a way we can specify which table we're talking about because we'll be sharing information in common. It's quite often that when you're talking about a table, say for example in the student schema we have right here, when you're talking about one of those tables, that they're going to have some of the same fields. And you want to make sure you're talking about the correct one. So use an alias, then a dot, and then the name of the column that we're talking about to make sure we have the right one. Great way to avoid confusion and other errors. And so to make an alias, all we have to do is just do the table name, then a space, and then the abbreviation that we're going to be using. I recommend 3 letters at least to make sure it's easy to use and not too hard to take care of. We also make sure we use at least 3 letters because say for example right here, I have grade conversion, grade type, and grade type weight. So I can't simply use G for that. It's going to get confusing. So I have to make sure I give a value that's actually going to be understandable. So I have GRA for grade and then GTW for grade type weight. I can tell what they are and make sure they make sense between that. As we do this, we're going to be using the ANSI join syntax to put together all of our queries from now on. And so we have our standard select, which I'm not putting on this because we don't have to worry about it. But then we have the from, where we specify just one table, the first table we're starting off with in our path along the join sequence. Then we join it to the next table we're talking to that we want to work with. Again, these both have the option of using aliases, and they're most likely will be there. Then we have our on clause. This is where I specify the match between the primary key of one table matching the foreign key of the other table, or if it's a composite primary key, the primary key and the foreign key matching up like this. So if you have that, you have to make sure they're separated with an and clause. Again, if I have multiple tables I'm looking with, each additional table will have an additional join on clause attached to it. So it's not just join, it's join on, because you need both clauses to make that happen. When do we do this? Well, from and join are both the selections of the table. So those have to happen very first. So from and join first. So the from, then the join. And then we use the on clause to restrict those that match based on that corresponding primary key, foreign key relationship. If they don't have a matching value, we're not even going to look at that. So that's the first restriction on the amount of rows that we're looking at. Then I call the where clause to restrict rows further, followed by group by, having if I need them. And then finally a select clause to identify the columns I'm getting the data out so I can go from there. We can see the execution order right here. So as you can see right here, my first is my from clause, student stu, and I'm joining zip code zip. So you can see also right here, I'm using the alias defined right there so I can easily identify which things I'm talking about. Then I move down to my on clause where I have zip.zip is the same as stu.zip. Okay, cool. And so I explicitly identifying that. Then I go to my where clause where I restrict the results and I only want to get cities that have a C in it. Okay, cool. Finally, I'm going to do my group by because I have a stu.zip column which is specified in my select clause and I have to make sure that they are grouped based on that number. Now I go up to my select clause, I do my average and count functions, get that information based on the groups, also get the zip code values for each of those things, and then I go through and order that by the student number ascending. Now there is a special case, a self-referential join, aka I'm talking to a table that not only has its own primary key, but a foreign key down here refers back to a different row of that same table. Now, this is often the case where we define something with itself, like, oh, there's a requirement for a previous version. In order to install macOS blah, 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 you have to have macOS blah already installed. Okay, cool. If you want to install the update to the latest game, you have to have the previous version of the game to do the update. You have to otherwise do the install. Yeah, so a self-referential join, just like you have to have a requirement inside yourself to do something. Now, the same rules apply for the join on sequence. However, it's really explicitly important that when we use our alias, that we use a fabulous one. We have to easily keep track of what we're talking about. Otherwise, we're getting really confused as to how we actually do this. So make sure you do a good make sure you make a good alias to avoid the ambiguous column error. Here we can see our quick, simple join example. This is what we've done in class a couple times. So first we have our from clause where I identify student stu. So I'm explicitly identifying my alias stu from student. It makes it really easy to identify what I'm talking about. Then joining that to zip code zip. Again, the first three letters makes it really easy to identify in this case because there's no confusion attached to it. Then in the on clause, stu.zip is the same as zip.zip, pretty easy. I go up to my select clause where I select student's first name and the zip code city. So I can now match students to cities as I go through the table. Great and easy. We have a more complex one right here where I'm going to use 3 tables as well as composite primary keys. So I have select gra.sectionID for my select clause, no worries, but I'm going to join from enrollment to grade. And remember back in that demo we just had, we have that there's 2 values in common. So you can see right here in my on clause, I have enter.studentID is the same as gra.studentID. So I have enter first, then grade second. And then and for the second half of that primary key pair, I have the GRA section ID is the same as ENR section ID. So again, it doesn't matter what order I do the primary key foreign key relationship as long as I order the correct values together. Then in third table, I'm going to join that to is the grade type weight and then GTW. I don't want to use GRA because I've already used that for grade, but GTW is also very easy to explain what I'm working with for an alias. And so GRA.grade type code is the same as GTW's grade type code, and the GRA section ID is the same as the GTW's section ID. So I can clearly see how that path is being built so I can get from one table to another and making sure I only get the ones that have the grade section ID. Now, a couple things we want to make sure we don't do. The first thing, never ever put comma separated values in your from clause. It makes it really hard to identify what the path is. You don't know how the relationship between the tables exists when you do that. Just because you name them in specific order doesn't mean there's actually a connection in that order. So you want to make sure you don't do that. It's also very easy to miss the appropriate connections between them because if you don't know the path, you may not know the actual primary key composite keys that go along with it. So you do not want to do the comma separated values in that from clause. Second, you do not want to do the connections between the primary key and foreign key values inside your where clause. Your where clause is designed to restrict the results based on logic, based on functions, not just randomly like, oh, I have a giant pile of tables I'm connecting, say I'm connecting 5 tables together. I don't want to have 10 lines minimum of text right there in my where clause just to do that. I want to have that organized so I can make those connections between the things first and then do the where clause to restrict my results appropriately. It also makes it hard to reuse our logic. We always want to make it so the code is easier for us as humans to read and then reuse again later. Finally, there's 2 things I don't want to ever see. I never want to see you using the using clause because that's joining based on a shared column name. Just because it's a shared column name doesn't mean it's the same thing. I mean, it may have a number in it, but a number actually means what it does. Again, we've already seen database samples where we have really poorly named columns. And if you have 2 really poorly named columns and you think they have the same thing, you might not be getting the correct results out of that. So it's a bad idea. Lastly, do not use natural join. If you're using natural join, it's going to join all the shared columns in common. And if I take a look at this, every single table in here has a modified date and a created date and a created by and then modified by. They all have those same values. However, there's a guarantee that none of them happen at the exact same second just because, again, you can't do everything all at the same time. So if you try and use that join, use a natural join, you're going to get 0 matches ever because the seconds difference between all of them make none of them match. So don't do that. So you can't guarantee names or value types on that. So never use natural join or using because they're not good policy. I hope this is helpful. Cheers. Have a great day. We'll see you next time. Bye-bye.